morning friends, myself Dr. M.H. Annaya, and in this video we are going to study the section of a hexagonal pyramid which is resting on one of its triangular faces on HP, and it is being cut by a section plane which is normal to VP, inclined to HP and passing through highest edge of the base. That is given here, passing through the highest edge of the base. And friends, how to start with this question now? Now it is been given that it has to rest on a triangular face on HP. Friends, in all the problems on pyramids, whenever it has to rest on one of the triangular faces, place the pyramid on HP such that one of the base edges, say ED, is normal to VP, obtain its top view and front view. In the top view, friends, you can see a regular hexagon of side 30 mm with the vertex O joined to all the corners A, B, C, D, E and F. These OA, OB, OC, etc. represent the top view of the slant edges which are given by O dash A dash, O dash B dash, O dash C dash, etc. And friends, here this front view is obtained by projecting lines from all these 6 corners, and the height of this solid is 60 millimeter. That's given in the question. Now friends, if you observe the front view, the last line, that is O dash, D dash, E dash, represents a triangular surface. And you can ask me how? Because there are 3 points, O dash, D dash and E dash. Whenever there are 3 points and above, that represents a surface. So here, this O dash, D dash, E dash represents a triangular surface of the solid. Even O dash, A dash, B dash also represents a triangular surface. Since we are going to tilt the object to the right, I am considering this O dash, D dash, E dash. Friends, after obtaining the front view and top view, let us make this drawing or make it to rest on the line O dash, D dash, E dash, which represents the triangular surface, one of the triangular surface of the solid that I have shown here. Now, figure number 1 and figure number 2 are exactly identical, excepting that it is resting on O dash, D dash, E dash, which is one of the triangular surfaces. Now friends, let's move on to the section plane. Here the section plane is normal to VP. You can see this, yes. Section plane is normal to VP, passing through the highest edge of the base. So here AB is one such edge. So it has to pass through that, but inclined at an angle he has given you 40 degrees to HP. So this angle, whatever is drawn here, is at an angle of 40 degrees. So friends, after this is cut, the upper portion of the solid is thrown out and we retain the lower part of this pyramid for drawing this section and other views. So this part of the solid is retained as shown. And now friends, corresponding to this, let us see how does the object look. Friends, when you see from the top, and I have told you in many of my previous videos that whenever any pyramid rests on HP, on one of its slant edge or on one of its triangular faces like the one we have got, the base of the pyramid is completely visible to the observer in the top view. So if it is a pentagonal pyramid, you get a pentagon here. If it is a square pyramid, you get a rectangle here. And if it is a hexagon, you get a hexagon. So friends, now I have drawn the top view of the solid by looking from the top, say T, and obtain the corners of the base, namely A, B, C, D, E, F, and all are visible here. The edge OA, OB is also visible. So OA is here, I have shown by full line. OB is here, again that is shown by a full line. Friends, after obtaining the top view, when the pyramid is resting on HP on one of these triangular surfaces, let us see where all the section plane is cutting the solid. The section plane SS is passing through AB, that is one of the edges of the base. So I have shown A as point number 1, B as point number 2. Then the slant edges OC and OF are cut here. I write a vertical line from there and obtain the point 6 and 5 on OC and OF. Finally, it is cutting the edges O dash D dash and O dash E dash. So I have just drawn line from there and I have got this O dash D dash points on O dash D dash and O dash E dash. So friends, since the solid is passing through AB, it will have 2 points. Cutting these two slant edges, it will have 4 more points. So there will be totally 6 points in the top view where you are going to add that section or section it. So friends, after this portion is removed as I have shown before. Only this much part of the solid is visible in the top view. So friends, this complete figure will give you STV, indicating it is sectional top view. Then friends, this figure will give you the front view. This is the front view of the hexagonal pyramid. Now we have to obtain TS of the section. TS means true shape of the section. True shape is nothing but it's the mirror image of the cut section of the solid. So if you hold a mirror parallel to this SS and see this part, you will be able to get the true shape. Then how to obtain the true shape? Friends, you draw some line at any convenient distance from this section plane SS parallel to it. And then from all these points 1, 2, 3, 6, 4, 5, etc. you draw lines perpendicular to that. So you are going to have all these lines drawn perpendicular to this section plane. And friends, after getting this, let us obtain the true shape of the section. Friends, here I will just rub this, and this true shape can be obtained very easily. We can start from any point of your choice. So I'll just mark these lines. Look at the board, friends. Now here we have to take the distances of points 1, 2, 3, etc. from XY and mark on these corresponding lines. Friends, 1 is here. Take this distance on line drawn through 1 and mark point 1. So this is point 1. Similarly, point 2 is here at this distance. So we will mark point 2 here. And remember friends, this 1 to 2 is parallel to this and is parallel to this. Hence it will have a dimension of 30 millimeter. So this is point 1, point 2. Similarly, on this line, we are going to get 3 and 6. So 6 is near, 3 is away. So we can have points like this. Finally friends, you have got 4 and 5. So we can obtain these points. This is 1, 2, 3. This is 4, 5 and 6. Friends, join all these points so obtained by straight lines. So I will join 2 to 3, then 2 to 3, 1 to 2, etc. and obtain this figure, which is the true shape of this object. So we have got this. Join all this by straight line, and this is the same procedure for all the pyramids. Now friends, 1, 2, 3, 4, 5, 6 represent 1, 2, 3, 4, 5, 6 represent the true shape of the section. And as per the convention, we have to section these by drawing lines at 45 degrees to the horizontal. So we have got these lines equispaced, and we have got this complete figure is called TS. It is the true shape of the section. We have got the sectional top view, we have the front view, and you have the true shape of the section, which is a hexagon but totally distorted. And remember, the distance between 1 and 2 is exactly 30, and that I have shown here. Friends, I hope the presentation was interesting. Please go through the complete video without skipping anything in between. And if you like this video, please share this video with all your friends and have a wonderful day. Thank you, friends, for watching my YouTube video.